Hey everybody, today I just wanted to share a tool with everyone. So this is a way to kind of simulate a Visa device. So you can practice kind of talking to Visa devices, get data back and forth. Also, if you maybe are setting up some code for communicating with a device and you don't have maybe the hardware yet, but you want to start programming, this is a good way. You can just run this and it will simulate your device, and then you can send commands and get responses back and forth. So what this does basically is just creates a TCP listener for incoming communications and responds. It's set up so you can load a list of requests and responses. This list just gets populated here. You also can go in and just type in different stuff. So if I want to add a new command, I can, and what the appropriate response for that command is. You can load these from just a delimited text file. And so I just have a demo file here. These are the commands that are supported in this file. Anything else will return an error, and I'll show you that. And before I run this, I need to specify the port that I want this to run on. So I just have 50,000. And as this is running, we'll see when messages come in, we'll see what that message is here. And when messages go out, we'll see what that message is going out. So just to demo here, let's do this first one. IDN ? And run this. So you can see here this message was received and it sent this message back. And over here as well, you see we got our simulated device back. Let's maybe do this Vault query and see what that looks like. I got a value back. Let's do something that's not included in the list. Response for request time not found. So you get basically this message that says, hey, whatever, there was no response for what you just asked for. So on the reading side, let's look at just how we're doing this. It's pretty basic. So I do have this sub VI here for formatting this socket. So basically we have this TCP IP, and then I'm adding in the IP address and the port. And then typecasting that to a Visa reference. That's not totally necessary. So you can just create a manual socket in NIMAX, and that way you could just have like a Visa dropdown, and just select your TCP socket right from like a Visa dropdown, like you would connect to like a COM port or something like that. Which, if you are interested in doing that, if you just click this help button, it actually walks you through right here in this middle section on the steps to do that, right? So, open NIMAX, expand devices interfaces, go to network devices, add network device, select Visa TCP IP resource, manual entry of raw socket, and you can enter these details. And now, if you follow that, it will just show up in like your Visa dropdowns and stuff. So you can do that. In my case, I don't want to go and configure NIMAX every time I need to do that. So you can just build this string basically with your IP address and your socket. In my case, it's localhost, but this also works over a network as well. Now, then we're just doing a Visa open with that new reference. And because this is TCP IP, we are using a line feed to terminate messages. So we are just taking this line feed, typecasting it to an integer, and then we're enabling termination characters and send and end enable. I'll do some other videos on Visa in the future, but basically everything in Visa is all handled basically in startup, right? Once you've gotten everything configured right, then your reads and your writes are all super simple. But yeah, so here we are just writing our buffer, which is just the command we want to send. And then we're going to read back data. So this read is waiting till either we get 1028 bytes back, or we get a termination character, which we've defined as a line feed. or we get a timeout. So the default timeout, if that occurs, then this will just move on. So one of those three things has to happen. And because we're using just termination characters, we don't have to wait for time to run out or anything, and it's very quick. So yeah, you can run these commands very quickly, get data back, and then we're just closing that connection afterwards. So that's all it really takes to program to talk to this. Now you can kind of use different commands if you're trying to simulate an actual hardware device, right? The hardware device won't necessarily communicate using this configuration. So you might need to just change your startup and maybe even add like a simulated mode, right? So, open simulated. So instead of running the regular, it will use this. And the nice thing is it automatically is adding like termination characters to the end of your commands for you. So you can just use the raw commands and it will include those after the fact. So this is pretty much it to communicate with it. You also don't have to use LabVIEW even. You could communicate with this simulated device in other languages. You could use like Visa test panels from NIMax as well and just read commands back and forth. And this simulator, this VisaSIM, is fully compatible with the runtime engine. So you can run this as an EXE as well. So let's look a little bit at how this is working. So we basically just have a producer consumer type thing going on here. So when we get our when someone selects a new command set, we're basically writing that set to the array. If we want to create a set, we're just launching this little dialog so that you can go in and enter your parameters, everything you want, and click save, and it's going to go save this to a delimited file so you can load it in the future. So you can create those files manually yourself, or there is this GUI here. You just need to click the create button and you get that little pop-up. Help. So this is that button I clicked here. It's just going to pop up some instructions on how to use this software. And log. So this is going to launch IOLog, which if you've never used IOLog, it is a very powerful tool for kind of debugging communications, specifically when you're working with Visa. It can be so helpful. So for example, I can start my logging, and I can run commands back and forth. I actually just closed out that communicator, but it'll basically track data going back and forth, but also even beyond that, it will capture things like Visa property changes and stuff on a very much smaller level than just, hey, what data is going back and forth. So it can be kind of useful for troubleshooting and debugging. So yeah, that's just set up. It just launches IO trace. This is where the actual communications is happening, down in this bottom loop. So we are just creating a TCP listener on whatever port we've specified. And this just waits 2 seconds and then it restarts. So you can kind of update that port on the fly. And it's just going to wait for someone to connect to it. If there's an error, it's basically just moving on. So check in if this top loop hasn't been shut down yet. If it has, then, if it hasn't, it just goes back to a listening state. Then we're just doing a TCP read. And if we get no data, right, we get a timeout, just moving on. If we do get data, we're going to go try to find if that is in our list of commands. So let's pull this up. And this is what we're doing here. We're basically just taking that request, looking in our list of requests, trying to find if that's in there, and if it is, giving the appropriate response. And then it's adding that line feed for you. And yeah, that's pretty much it. It just does that over and over and over again, and closes itself out at the end. So that's all it is, but kind of cool tool for being able to basically just simulate a Visa device. So I can just send commands back and forth, get data back and forth, and I can either practice using Visa, or I can basically simulate different hardware devices. I can even just build a text file of all the commands that device supports, and then just basically run simulated communications back and forth to it. So this is all free, open source. If you guys are interested in this, the link to the repository is in the description for the video. You're welcome to take it and use it as is, or modify it as you best see fit. But yeah, thank you guys for tuning in.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.